Assalamualaikum. My project for final year project is development of drone navigation system for fertilizing durian tree. Before I start, I will introduce myself. My name is Sharafina Solihah binti Salihuddin, and this is my supervisor, Dr. Muhammad Khairi bin Muhammad Noor. This is my Gantt chart to show progress every week for my project, start from week 1 until week 40. From this Gantt chart, I have successfully completed in allocated time. In this video, I will present 3 chapters, including introduction, summary of literature review, and methodology. I will start with chapter 1, introduction. Introduction. Drone advocates have cited precious crop management in agriculture for years now, which use GPS and big data as a means to maximize crop production while addressing water and food crisis. It had increasingly taken place on the topic of drone technology in agriculture and precision farming. There are too many advances in precision agriculture in the period to increase crop productivity. Due to pests, the agricultural field face dramatic losses. These diseases are caused by pests and insects which reduce crop production. To increase crop production, chemical and fertilizer are used to kill insects and pests. The World Health Organization reported that when spraying the fertilizer in crop field manually, 1 million cases of illness were caused. A drone will quickly be used. Next, this is my problem statement and objective. Problem statement. Durian trees, especially from leaf growth stage until durian tree preparation for flowering stage, require proper care and a foliar fertilizer in the right quantity, referring to the frequency of fertilization each month. Moreover, at this stage, only 50% of durian trees will survive if not fertilized properly. Because of that, to facilitate the fertilization of durian trees and reduce worker fatigue, drone can solve this problem. Next, my objective. The objective of this project is to develop navigation system for drone to do fertilizing tasks. Next, this is my flowchart for this project. First, start. Next, drone will read GPS position of delivery point. After that, drone will take off from the base point. Next, drone will fly to delivery point and make 2 rounds while spraying durian fertilizer. After that, it will take off from delivery point and return back to base point. This is my flowchart of preliminary design process. Now I will enter for chapter 2, literature review. Introduction. Precision farming is a method of controlling the capital of crop yield such as water, fertilizer, land, seed in order to maximize efficiency, quality, benefit, and decrease squandering goods so that the current method becomes environmentally sustainable. The role of UAV in our society is becoming increasingly important, and the number of flying drones is rising exponentially. Unmanned aerial vehicles were born for combat reasons or sometimes referred to as drones, but in many commercial use they have expanded in recent years. This is my summary of research. For overall summary from previous research projects that have been reviewed, There are several methods, techniques, or ideas that can be used or implemented in development of drone navigation system for fertilizing durian tree project. The first criteria that need to be chosen are the type of drone. From the research, the best type of drone for this project is using quadcopter. Propose the quadcopter system, which are low cost and also lightweight. The quadcopter is also known as unmanned aerial vehicle. This quadcopter is small in size, and this system can be used for indoor crops and also outdoor crops. Quadcopter is an autonomous flight for spraying fertilizer using the Android device. Between the quadcopter and Android device, communication is by Bluetooth device in real-time operation. This system is used to reduce agricultural feed-related problem and also increase the yield of agriculture. Sustainable agriculture is concept in which the drone potential is the best reflected and shed light on the future of the agricultural food system, and drones are the key sources of the ultimate goal to achieve a truly sustainable agriculture. Drones commonly navigate using computer vision, or more popularly known as simultaneous localization and mapping (SLAM), to generate a map of their surrounding, including the obstacle. That method is imperfect. However, if an object is just slightly out of place, the drone will crash into it. NanoMap forgoes the map and instead navigates around obstacles and sees them. Although this approach is faster than mapping everything first, the trade-off is that the drone has reduced understanding of its overall environment. Next, the last part of chapter 3 for methodology. Introduction. The spraying mechanism mainly consists of a microcontroller which is programmed to perform various functions. It also contains a tank of 1000 ml capacity to which a water pump is connected. To this pump, a splitter connected that split the chemical to the two nozzles that square measure connected at two opposite ends, and spraying is achieved. It additionally contains a motor driver circuit to manage speed of spraying and chemical level indicator circuit with buzzer for indicating once the chemical is empty. This figure is about typical quadcopter layout. The first part is propeller. The drone major load applied can accommodate the speed it can fly and the speed it can navigate. Longer propeller can adjust the length and achieve greater lift at higher lift. Higher speed by accelerating or slowing down takes longer. This induces excess motor strain and thus decrease the length of motor life. A more violent pitch would allow faster travel but decrease the efficiency of hovering. The second part is motor. Drone motor are rated 1 per propeller in kilovolt units, which refer to the amount of revolution per minute that can be accomplished when the motor is supplied with a voltage of 1 volt without load. A quicker spin of the motor can provide more flight power but more battery power, resulting in shorter flight time. The third part is electronic speed controller (ESC). Each motor provides a control current to achieve the proper speed and direction of speed. Next, flight controller. An onboard computer that interprets the incoming signal sent by the pilot and sends the related input to the quadcopter powered ESC. After that, radio receiver. Radio receiver is function for collect the pilot power signal. Lastly, battery. Due to high power density and capacity to regenerate, lithium polymer battery are commonly used. Okay, this figure is about simulation procedure. As you can see, this is remote, drone, and pump. And communication between remote and drone is turn it on, connection established, input control, input accepted, waiting for input, activate pump deactive, shut down and disconnect. And between drone and pump we active and do a spraying, and pump will deactive. This is my block diagram of quadcopter. Okay, as a conclusion, this is my flowchart for this project. First, start, next drone will read GPS position of the delivery point. After that, drone will take off from base point. Next, drone will fly to delivery point and make 2 rounds while spraying Durian fertilizer. After that, it will take off from delivery point and return back to the base point. That's all from my final year project 1 for this semester. If have any inquiry or questions, feel free to contact me by email or number phones. Thank you for watching this video. Assalamualaikum.